Welcome everyone, and thanks for taking the time to watch this video, which explores past and current research that has been done to understand the experience of immersion as it relates to user experience within the context of playing video games. User or player experience is well rooted in human-computer interaction. In this context, user experience can be seen as an umbrella term that illustrates the summative subjective interplay between the digital world of computation and the ethereal realms of the human psyche. In other words, user experience serves as a metric on how well we're able to communicate with and relate to our computer software, a relationship which itself is highly coupled to the complex interplay of both human and computational factors. But before we begin, I'd like to note that there are quite a few slides in this presentation, so please feel free to pause this video at any time if there's something that catches your eye. For the majority of this video, we'll be looking at game immersion research through the lens of a research paper written and published in the International Journal of Human-Computer Studies in 2008. Its title, Measuring and Defining the Experience of Immersion in Games. The paper can be downloaded from multiple online venues, including the one below, which allows for free access to the PDF document of the paper itself. You can also grab it from the Science Direct website through your local university library, which in the case of COMP648 is the University of Athabasca. Of the 7 researchers that wrote the paper, 5 of them were experts in human-computer interaction. Of those 5, 4 came from the University of London College, and 1 came from York University in Ontario, Canada. The other 2 were UX consultants from Bunnyfoot Behavioral Research Consultancy. As you can see, this was an international collaboration between researchers who wished to study immersion in a gaming context. Before we get into the nitty-gritty details of the research paper, let's just take a moment to step back and explore what immersion actually means, at least on an intuitive level. If I were to describe immersion, I would describe it as an intense, subjective, cognitive, and potentially emotional experience that often is transient by nature and whose intensity varies depending on the medium and depending on the factors that are going on in your psyche. It is also very contextual to the medium, meaning that the immersive experience you feel while reading a newspaper may not be the same immersive experience you feel while watching a good movie, or a bad one for that matter. As you can see, immersion is subjective, and as such, there are many definitions of what immersion actually means. So why is research into immersion important? Well, generally research has shown that instruments that provide immersive experiences tend to be more attractive to people. The study of immersion with respect to HCI could also lead to better designed software from both qualitative and quantitative aspects, and it also has potential use in learning contexts. Why is research into game immersion important? Immersion is often seen as a critical characteristic associated with good game design. As of 2016, video games represented a $99.6 billion industry, and unlike other mediums, video games are capable of being interactive or engaging in a way that's just simply not possible with other mediums. There has also been research into educational or serious games that have shown positive results when it comes to providing motivational means to promote learning. And last but not least, there is potential for gaining a better understanding of the psychological mechanisms that lead to game addiction. Now that we talked about why immersion is important, or research into immersion, let's talk about what researchers believe about immersion. So the first is that if someone is immersed, they generally have a lack of awareness of time, called temporal dissociation. Also, they tend to have a loss of awareness in the real world, called real-world dissociation. And there is a sense or involvement of being present in the actual medium, called transportation or presence. So now that we discussed what researchers believe to be the immersive effects of immersion, let's talk about the research questions outlined in this paper. And these research questions are fourfold. The first is, can we define what immersion is? From this definition, can we create an instrument for essentially gauging immersive experiences with respect to gameplay? And also, once we have defined immersion, can we also create objective ways of measuring immersion during gameplay? And finally, is there a relationship between game pacing and immersion felt by players? In general, researchers want to figure out whether or not immersion actually has a representative emotional binding. So does immersion actually affect your emotional state? In order to begin to answer the questions outlined before them, researchers looked into prior research of immersion to determine if an objective immersion definition could be found, and one was. In 2004, a qualitative study by Brown and Carnes was conducted with 7 particular gamers to determine what it was in fact that these gamers were experiencing when they were experiencing immersion. Grounded theory determined that there were 3 degrees of player immersion. Each degree of immersion requires a player to overcome barriers in prior levels of immersion in order to move to the next higher level of immersion. According to the grounded theory, these degrees or levels begin with engagement, followed by engrossment, and finally entering into true immersion. This slide illustrates the grounded theory of immersion. As you can see, there are 3 concentric circles, each one denoting the different levels of immersion. In general, immersion is linear, meaning that you have to go from engagement to engrossment to true immersion. Now, there are barriers that prevent you from doing that. Those barriers essentially are dependent on the style or type of immersive state that you're in. In an engagement state, which is denoted as the state in which a player is interested and keeps wanting to play, there is a sense of lack of emotional attachment. In order to get past or into the next levels of engrossment and true immersion, you have to essentially break through the different barriers. The first barrier is from engagement to engrossment, and this barrier is known as access. Access is generally conditioned on the gamer preferences, the game's controls, meaning UI or game mechanics. So essentially there are human as well as computer or computational factors that prevent access or prevent ascension into the next levels of immersion. Another thing that has to be done is the player actually has to invest their resources, cognitive as well as time, in order to get through each of the levels of immersion. Engrossment is essentially engagement, but with an emotional attachment. At this point in time, most of the emotional investment has been established and the gamer's attention is inside the game. And at this point, temporal dissociation begins to occur. And their suspense in the world or disbelief in the current world, the real world, is diminished. So they're starting to essentially transport themselves into the game at this point. However, this transportation is not complete until they reach true immersion. At true immersion, they are essentially fully engrossed in the game and they feel a sense of presence. To get from engrossment to true immersion, one must overcome the barrier of game construction. And the researchers define game construction as essentially the features or characteristics of the game. So for example, the game mechanics, the UI, the atmosphere, the ability to empathize with the characters. These are all things that one must overcome or at least surpass in order to achieve the final level of true immersion, in which you essentially lose track of reality and you are actually inside the game. And this experience is often fleeting. So at any point in time, there may be a distractor that appears that pulls you out of those levels, whether you're in true immersion, engrossment, or engagement. In addition to the grounded theory of immersion, researchers investigated related studies into immersion to see if more comparisons into immersion could be found. In particular, researchers found parallels in 3 different areas: cognitive absorption, flow theory, and presence. Cognitive absorption is defined as a state of deep cognitive engagement with software. It's derived from psychological absorption theory, flow theory, and the notion of cognitive engagement. It is influenced by personality traits and is exhibited through 5 dimensions, which the software essentially tries or achieves through the user. The first is temporal dissociation. So the use of the software actually causes essentially a loss in time. The second is attention focus. So the software exhibits the ability to grab your attention and keep it focused. The third is heightened enjoyment. So the use of the software actually increases the enjoyment of the user over time. The fourth is control. So the software gives the user the sense that the user is in fact in control and can do what is needed to be done to achieve the goals outlined by the software. The final dimension is curiosity, and that is the ability for the software to incite essentially to incite playfulness within the user. So does it cause the user to want to explore the features or functionalities of that system? In general, cognitive absorption deals with the whole of the system, so the attitude towards a system. It does not deal with the actual point in time engagement. So therefore, this particular definition was used along with others to augment the definition of immersion as founded in the grounded theory. Flow is well known in psychology circles and is seen as the psychology of optimal experience. Experiencing flow is often compared to the feeling of being in the zone. In order to experience flow, Mahi proposes 8 components, 3 of which must be characteristic of the activity or task being performed. These prerequisite components are clarity of goals and immediate feedback, high concentration on a limited field, and balance between skills and challenge. The final dimensions are feeling of control, feeling of effortlessness, altered perception of time, melding of action and consequence, and the process and outcomes of performing the task is fulfilling. So essentially, you're doing the task for the sake of the task. Presence was the final area that researchers looked into in order to achieve further clarification into the underpinnings of immersion. According to research, presence is defined as the fleeting experience of feeling as if you're part of another world that is distinct from the reality from which you exist. This slide illustrates how researchers combine several areas of research to define their concept of immersion in the context of player immersion and how that leads to contributing towards player experience. From this definition, the first version of the immersion questionnaire was created. The questionnaire derived many of its questions from prior questionnaires that have been established and validated via prior studies of researchers in their respective areas of cognitive absorption, flow, and presence. From the development of the questionnaire, the instrument was applied as a subjective measure of immersion across 3 experiments, which were conducted in order to determine if there are other objective measures of immersion that could be determined. The questionnaire itself is a 5-point Likert scale-based instrument, which existed as 2 versions. An initial version, which was used to gauge immersion in the first 2 experiments, and the final version, which was refined based on feedback accumulated from the prior 2 experiments and administered for the 3rd experiment. In general, the questionnaire gauged player immersion levels by using a multi-measure set of questions, as well as a single rate my immersion scale from 1 to 10, 10 being the most immersed style of question. Reliability of the first version of the questionnaire was performed during the 2nd experiment using single and multi-measures responses from the experiment to attain correlation between the 2 measures, which was found significant. The final version included simplified wording and only 31 questions. The first version included 33 questions, 16 pairs of 2 questions that measured a particular factor that was derived from the definition of immersion we mentioned before. The final version of the questionnaires validity was performed upfront rather than in the 2nd experiment, as was the first version, using the responses of 244 online gamer responses and principal component analysis to reduce the extraneous factors, along with factor analysis to ensure that the modified version was still valid. Before beginning to talk about the experiments, let's take another detour to ensure that we understand the premise of the comparators used for the majority of the experiments performed in the study. The high immersion task used in experiments 1 and 2, followed by the low immersion task respectively. The low immersion task was used in all 3 experiments, albeit modified for the last experiment. The first experiment, what you see here on screen, is our high immersion task, which is based off the popular 3D first-person shooter Half-Life. Half-Life was modified to contain 2 stages, a tutorial-like stage called the Hazard Training Course, which allowed participants to learn the game's controls and the actual game itself. To help users learn controls, a hard copy of the game's controls was provided, essentially a cheat sheet, and placed in front of participants for easy reference during the experiment. It is also important to note that participants could choose to end the hazard training course at any time during the duration of the experiment for the experimental condition. This would allow users to feel like they were in quote-unquote control of when and how they chose to play. In addition, to increase immersion, the game's soundtrack was allowed to be played during the duration of the experiment. The low immersion task was a custom Windows-based application that spawned randomly positioned squares within a 9x9 invisible coordinate system. Clicking on the square caused the square to disappear and immediately reappear in a randomly selected location that was bounded within the coordinate system. To decrease the likelihood of potential immersion, no audio was provided during the duration of the experiment and across experiments. Now let's delve into our first experiment. But first, let me introduce you to Tangram, a 7-piece Chinese puzzle game. The objective of this game is to view a picture of an object and, using the picture as a reference, rearrange the puzzle pieces, which is often configured into a square, as seen on the right side of the screen, to construct the desired object. For experiment 1, the Tangram puzzle was to serve as a pre-test and post-test task to determine if the level of immersion experienced by a person had an objective effect on the task completion time. It is important to note that the Tangram task was selected by researchers because pilots demonstrated that Tangram task performance is affected by familiarity of the puzzle. Researchers had two hypotheses. The first one was the level of immersion in playing the game will be higher than the level of immersion in the control activity. The second hypothesis was the improvement in task performance as measured by task completion time will be less in the experimental condition, i.e. the game, than the control condition, i.e. the square clicking task. The first experiment used independent measure design to perform their experiment. With independent measure design, the treatment is applied only once and to only one group. In total, 40 participants, 30 female and 10 male, were recruited from London University and assigned into either the non-immersive or control condition or the immersive experimental condition. The mean average age was 21 with a standard deviation of 3.51. The experiment 1 condition procedure was as follows. The first task for both groups was to do the Tangram puzzle. Once this puzzle was completed, the completion time was recorded. The second task depended on which group you fell into. For the non-immersive, this task was the square clicking task. And for the immersive group, this task was in fact the game. Each of the two groups performed the task for 10 minutes, after which they were given the immersion questionnaire that was developed earlier. Finally, they did the same task that they started for another 10 minutes. At the end of this, the post-test was applied, which again was the same puzzle they were given in the pre-test, which was a picture of a fox. Experiment 1 results was as follows. The first hypothesis was supported. That is, people reported the non-immersive task as being less immersive than the immersive task. The second hypothesis, however, was only partially supported. What they found was, across the group, the correlation of the immersion score, delta task time, had a Spearman's correlation of phi negative 0.45, with a probability of less than 1%. What that means is essentially that the more immersed you were, the less time delta between the first puzzle and the last puzzle, which is essentially the improvement time. However, Group A did not show significant correlation between the immersion score and delta time. Post-test completion times of the second gram test task was performed, but again, Groups A and B task times was not significant. Experiment 2 wanted to determine whether or not eye tracking could be used to measure the amount of immersion felt by a particular participant who may or may not be immersed, and what the relationship was between the two. The first hypothesis was similar to the first hypothesis in experiment 1. That is, the level of immersion in playing in the immersive condition will be higher than the level of immersion in the non-immersive condition. The second hypothesis was that participants in the immersive condition will show different change in eye movements, i.e. number of fixations, over time than the participants in the non-immersive condition. And finally, the third condition was subjective self-reported immersion ratings will correlate with the changes in eye movements. Like experiment 1, experiment 2 used independent measure design. However, opportunity sampling was also mentioning. What that basically means is that they recruited essentially whoever was available. Of the total participants, being 41, 19 were female and 22 were male, between the ages of 18 to 39 with a mean of 25.39. Random assignment of 21 in the non-immersive condition and 20 in the immersive condition. 4 people, however, were removed from the analysis due to issues with eye tracking. Each of the participants were paid £6 for volunteering. Experiment 2 procedure began with participants being given each a personality questionnaire, which measured 2 personality traits thought to be linked to immersion: absorption and openness to experience. We'll get to that later. However, this particular questionnaire was not included in this analysis. Also, anterior and lateral cameras were placed towards the participant and to the side of the participant to analyze body motion. Analysis was not really included in this paper. In total, like experiment 1, there were 2 groups that were randomly assigned: the non-immersive condition A and the immersive condition B. The tasks were the same as they were in the first experiment, i.e. they used the game or the square clicking task. Pupil tracking software hardware was calibrated for each of the participants. Groups performed either the immersive or non-immersive task, i.e. the game or a square clicking task respectively, for 10 minutes, not including practice time, after which they filled out the same immersion questionnaire used in experiment 1. Experiment 2 results were as follows. 4 participants were excluded due to eye tracking issues. As was the case with the first experiment, hypothesis 1 was supported. The non-immersive condition immersion multi-question score was 44.9 out of 100, with a single measure score of 3.9. The immersive score condition was 66 out of 100, and that was a mean. And the single score was 6.3. The second hypothesis was also supported. In the immersive condition, represented by the lower left-hand side graph, it is important to note that these graphs actually represent the number of fixations per second. So in fact, what that means is you are more fixated in the immersive condition than you are in the non-immersive condition. The third hypothesis was partially supported, and they found some issues with it. And so they performed a qualitative analysis, choosing 4 of the highest and 4 of the lowest from each of the 2 groups. And then they performed analysis on each of those people, as well as interviews. What they found was, for the group that was less immersed, for people who reported low immersion scores, essentially in group A, their eye fixation rate significantly increased over time. However, for the low immersive condition A, who reported high immersion scores, their fixation rates did not change significantly. For the high immersion or experimental group B, those who scored low on immersion had no significant changes over time as well. Alternatively, those who reported high immersion in group B, or the experimental group, significantly showed reduced rate of eye fixations over time, and that time was measured between 5 and 10 minutes into the session. The logic behind that was essentially that researchers believed that since investment in time was required to be immersed, that the first 5 minutes would not be significant, and so they only measured the second half. It is also important to mention that this particular decision to only measure the second half of the task time was also applied to the initial group. The motivation behind experiment 3 comes from the findings of experiment 2, in which researchers were surprised to find that some participants actually rated the supposedly non-immersive task as highly immersive. Experiment 3 aims to investigate the relationship between immersion and pace of interaction with the computer interface by comparing the subjective ratings of immersion and state anxiety of participants within 4 speed conditions: externally paced conditions, slow, fast, increasing, and non-external, self-paced condition. The first hypothesis was that participants in the 4 speed conditions will vary in terms of the amount of immersion they experience. The relationship has been summarized below in the formula. The second hypothesis was that participants in the 4 speed conditions will also vary in terms of the amount of state anxiety they feel, measured by the state anxiety questionnaire. Again, I've summarized the actual logical relationship that they wish to find. The third hypothesis was, as well as state anxiety, participants in the 4 speed conditions will differ in levels of other affective states, measured by the PAN-X, namely positive and negative effects. Like the 2 other experiments, experiment 3 was an independent measure design. It also used opportunity sampling. There were 36 participants, 19 were female, 17 were male, ranging from the ages of 17 to 42 with a mean of 24.6. Random assignment was used to place each of the participants in one of the 4 groups. The procedure of the experiment 3 was as follows. Like experiment 2, 2 cameras were used, set up in a similar fashion as experiment 2. In addition, biosensors to measure stress levels were also used. However, the analysis was not included in this paper. As this is an independent design, each participant was exposed to only one of the pacing conditions for 10 minutes, after which they filled out the newly revised 31-question immersion questionnaire, along with the State Anxiety Questionnaire and a PAN-X questionnaire. For motivation, participants were told that the participant that performed the best in the task would get a prize. Experiment 3 results was as follows. For the first hypothesis, the ordered relationship was not supported. For the second hypothesis, the differences between conditions were highly significant, with a probability of less than 1%. Similarly, the third hypothesis also showed that the increasing condition experienced significantly more negative effects than participants in the slow condition. The conclusions of the researchers are based off the experimental analysis performed in the study. The conclusions of the researchers are based off the experimental analysis and findings from each of the experiments. From the findings of Experiment 1, based on task completion time, researchers suggest that becoming increasingly immersed in a game decreases a user's ability to re-engage in the real world. From Experiment 2's eye tracking results or analysis, researchers suggest eye movements of individuals would decrease over time, focusing on elements of the game's visual UI as they become more immersed. Finally, from Experiment 3, Pacing and Immersion, researchers suggest that emotional involvement appears to be a key factor in immersion. Future work involves finding stronger evidence that supports the researchers' definition of immersion. As well, the immersion and questionnaire is also to be further developed, and more appropriate game comparisons are to be made. Also, more objective measures are expected to be explored, such as the biosensor data information and body analysis data that was taken but not included in this study. Investigation of the relationship between personality traits and immersion is also a topic of interest. It should be noted that those who score high in absorption and openness tend to be more susceptible to external stimuli or prone to fantasy. Researchers also indicated the interest in investigating differences in gender. So here's my critique. In general, times for testing immersion may not have been sufficient enough to truly measure the immersive experience, given that we don't know what the experience of the participant is in terms of playing games. They may have been overwhelmed by the controls, or they may not have liked the game at all. We simply do not know what factors were involved in reaching the actual data that was found. Also, question reliability and validity of version 1 of the immersion questionnaire was not undertaken until Experiment 2, which is, I find, a bit strange, since most papers I've read usually performs this beforehand. Potential confounding variables, as I mentioned earlier, like gaming experience, gaming preferences, and attitudes were not considered. Given that these are barriers according to their own definition of immersion, this may have biased their results, and may be why they led to inconclusive results in some of their findings. Letting people know that they would be interrupted may have also influenced immersion results. Researchers did not include potential information. This information included biometrics as well as personality metrics. I'm not certain why that happened, because it seems like these would be the type of things that you would be interested in measuring alongside with the data. Perhaps it was too complicated, or the data was complex enough that analysis was not ready at the point of composure of the report. So let's get on to specifics. So let's start with Experiment 1. Random assignment of two groups or conditions was not mentioned, potentially leading to a higher likelihood of bias introduced by confounding variables. Also, lack of correlation found in the control group reduces internal validity, i.e., the causal association between immersion and task time differences. It may be that there are different reasons for reaching the same results. For example, perhaps the particular participants were overwhelmed by the tangram task, and in addition, were overwhelmed by the immersive task because of the complexity of the 3D realm. This may have led to the lack of learning between pre-test and post-test, leading to varied results, which happen to skew the correlation. For Experiment 2, analyzing the full spectrum of fixation data from T0, meaning the beginning, to T10 could have helped to create a better picture in terms of illustrating what was happening with the participants. It would also have been useful to see if the definition of immersion that they'd chosen was valid, i.e., if the time invested equals greater immersion for those immersed. Secondly, selection of the highest and lowest scoring outliers, for example, in immersion participants from both groups introduces selection bias, which may not be representative of the real population. For Experiment 3, The design of the external pace tasks appears to manipulate both pace and UI responsiveness, i.e. two variables. The reason for this is researchers explain that the externally controlled task does not depend on the user actually clicking on the square. Whether or not the user clicks on the square is irrelevant in terms of how it responds, i.e., for example, for the externally controlled task of the high-paced condition, it didn't matter whether or not you clicked on it for it to disappear and or appear. Had you had the chance to click on it quickly, for example, it would not have an effect. So therefore, there could be in fact a frustration factor as well as an anxiety factor that's being measured. Secondly, motivation of being promised an award appeared to increase the immersion experience when comparing the self-paced task, which was essentially the control task for the first two experiments, to the actual final task. The immersion scores, if you refer back to the slides, you'll see that there actually is quite a bit of a difference in scoring of immersion, which means that motivational factors may have been involved, and probably were, and so that potentially could be a direction that the researchers could follow in future experiments. Finally, let's get into related research. In 2016, a paper was published entitled Measuring Participants' Immersion in Healthcare Simulations, the Development of an Instrument. The aim of the study was to create a non-intrusive instrument that could be used to measure immersion among participants in live healthcare simulations. They called this tool that emerged from the study the ISRI, or Immersion Score Rating Instrument. The actual study used qualitative methods, i.e. 24 recorded videos of the participants in the simulations. From these videos, subject matter experts identified event triggers, or essentially markers, within the video that denoted increased or decreased levels of immersion. They used this to create 10 identifiable triggers from which they performed analysis and compared that to the immersion questionnaire we mentioned earlier. The result was a tool which was proven to be reliable and valid in terms of rating scoring through a time span. This scoring system essentially used weighted immersion scores, which could be taken on a minute basis by a subject matter expert who could watch the participant videos. The second paper that I read was entitled How to Describe and Measure Obstacles in a Narrative Immersion of Film. The aim of the study was to describe and measure obstacles of narrative immersion in a film. In this particular study, they proposed a modified version of the grounded theory of immersion. They called Wheel of Immersion. We'll show this slide separately. Within the study, they used a mixed method: qualitative observation, structured interviews, as well as a quantitative 5-point Likert scale questionnaire. The study showed that viewers to a short film exposed can reach total immersion despite being exposed to frequent distractions. Immersion could also be maintained even though distractors, auditory and visual, were put in place. Here is the wheel of immersion in action. As you can see, it is not linear, and therefore you can actually come in and out of immersive states relatively quickly and more fluidly. As you can see, the obstacles are a bit different from those I defined earlier, and they are more contextual to the film genre. However, they are for the most part similar and can be used comparatively, as well as to show that immersion is in fact an overlapping experience, even if it's seen in different genres. Speaking of different genres, in 2014, there was a study that was conducted to measure user experience in board games. The aim of the study was to assess whether a questionnaire developed for digital games, namely the Games Experience Questionnaire, could be used for non-digital board games. The general motivation was to determine if there was an overlap between user experience criteria between physical board game styles and interactive digital games. In this case, Risk StarCraft, the board game, was used as a comparator. Another potential instrument that was evaluated by the researcher was the immersion questionnaire we mentioned earlier, but analysis revealed that it wasn't an appropriate measure because the context was too specific to the video game genre. Mixed methods was used during the study in the form of qualitative structured narrative player interviews, as well as quantitative 5-point Likert scale questionnaires from which the GEQ was formed. GEQ reliability proved very high, with Cronbach's alpha equaling 0.955, and validity analysis was done using the same 7 UX criterion that was used for scoring or qualitative coding of the narrative interviews. The GEQ and narrative interviews scored correlated highly, with a Pearson's correlation of 0.82 probability less than 5%. Therefore, it is shown that it is possible to use a digital user experience game instrument to measure the experiences of physical board games. This finding indicates that there is much more in common with immersion across genres than meets the eye, and so research into immersion is definitely a worthwhile endeavor. The next few slides just show the references that were used during this presentation. If you like, you can take these references and read the papers for yourself. I would highly suggest it. If you have any questions about any of the content or information that I presented during this video, please feel free to contact me through the message board. Thank you.